Welcome to homework.
All right, we're going to be doing chapter 16, problem 26 from Chemistry, the Central Science by Brown, the 14th edition. And the question's asking us to predict the products of the following acid-base reactions and predict whether equilibrium lies to the left or to the right of the reaction. So the first thing we're going to have to do for each of the questions is finish off the reaction. So first we have NH4 plus OH minus, and that is going to go to NH3 because that OH is going to take the hydrogen from the NH4 plus. So therefore we have an NH3 plus an H2O. And then for the next problem, we're going to just finish the reactions for all of them. We have a CH3COO minus plus H3O plus. And what's going to happen is that a hydrogen from this H3O is going to be added to the HCO minus. So now we're going to have CH3COOH plus H2O. And then now for the last one, we're going to have an HCO3 aqueous plus F cube. And then what's going to happen is that this H is going to be added to that F right here. And so now we're going to have the CO3 2 minus plus HF. All right, since now we have all the reactions finished, now we can figure out what are we going to use to compare in the equation to be able to figure out which way it's going to shift. So the best way to do this is to figure out which one is the strongest, and then from there, it is going to be pushing the opposite way. And so in this equation, we automatically can see that there's an OH in this equation. And then we can figure out what is its conjugate acid or conjugate base equation. So we have NH4 plus and OH minus. We know that this is a base and that this is the acid. And therefore, we have a conjugate base right here. And it's conjugate acid over here. And so whenever you're looking at the OH minus, this is a stronger base than the conjugate base on the other side of NH3. And so since this OH minus is stronger, the reaction is going to lie to the right. All right. And so for question B, we have a CH3COO and an H3O plus, and this H3O plus donated a proton or a hydrogen to the CH3O. So this is going to be our acid, and this is defined by our Bronson-Lowry acid and base. And this is our base, and therefore we can find our conjugate acid and base from over here. And so since this is our conjugate base, to find its conjugate acid, it has a plus proton. So this is our conjugate acid, and this is our conjugate base. And we're going to compare our conjugates to each other to determine which one's stronger, if the conjugate acid or the conjugate base is stronger than its regular base. So here we have a strong base compared to H2O. And so therefore, the stronger base is on the left side, so therefore it will push your reaction towards the right. All right, and then the last question, we have HCO3 minus plus F minus, which then produces the CO3 2 minus plus HF. And we're here to need to figure out which one's our acid and which one's our base. Since this H is being donated, this is going to be our acid. And then this F minus is accepting, so therefore it is our base. And therefore we know that this is our conjugate base and this is our conjugate acid. And now that we know that, we can then compare our bases to each other. And so this, we have the F minus and then the CO2 3 2 minus, and this F minus is actually a pretty weak base, and then CO3 2 minus is a very strong base in comparison to the F minus, and so therefore it's going to push our reaction to the left.